Zoop. So today you learned the final type of factoring that we're going to talk about in this class. And then after this, we're going to put it all together and mixed bag it. That'll be a rough week. So enjoy these next couple days. This ought to be smooth and easy. Factoring by grouping is an absolute cakewalk. Um, there will be multi-step problems, right? Just like before. So those are always going to be in play now, the multi-steps. After today, and we work today, we might work a little bit on this Monday. Then comes the mixed bag assignments, where now your assignments are going to be quadratics, cubes, lookalikes, grouping, the whole shebang, all blended. So what's been nice so far is like, okay, give me a quiz and make me do 12 of all the same kind. Okay, that's fine, but it gets a little bit harder when they mix up. So you guys have handled this all really well, though. Not worried about you. Anyways, grouping is today, and I'm going to do 9 examples, unless I feel like that's too much. So here's what your problems are going to look like. Grouping is the strategy you are generally going to use if your polynomial has 4 terms. So, what's going to happen starting next week is you're going to have to be really good at looking at a problem and saying what it is. Oh, it's one of those, or it's one of those, or it's one of those. And the tell for grouping's the most obvious one because it's going to have 4 terms. And none of the others that we've done have had 4. Quadratics, most lookalikes have had 3, difference of squares, cubes, they're pretty recognizable. But grouping just sticks out like a sore thumb. So this is what they look like. X to the third minus 4x squared plus 3x minus 12. And as I try to always do, I'm going to give you some steps, pretty concrete steps to follow. So next week, I will add a step to all of these problems. Step 1 next week is going to become find the GCF, but I've been avoiding GCFs to this point on purpose. So our current temporary step 1 is to do this. You're going to grab your pencil and you're going to build a wall right there. You don't have to build a wall. That's of course just a me thing. But what I found is it helps us. It's a visual reminder of what we're about to have to do. So what we just did is we created groups. We have the first 2 terms of the polynomial make a group, and the back 2 terms make their own group. And what we're going to do is we're going to factor each one independent of the other. So fortunately, today we do get to talk a little bit about GCF. And so today, for the first time, we get to recognize what does it mean to pull out a GCF? Well, if you look at just the first 2 terms, so do not look at anything beyond the purple wall. If you were to look just at that, what do you see that they both have in common? Do better. Specifically, what do they both have in possession? No. How many X's? One has 3 and one has 2. So what's the greatest amount that I could reach in and pull out of both of them at the same time? 2. There you go. So that's your first dive into the concept of a GCF. The idea is what's the greatest amount that's common to both of them? And you say, yeah, they both have X's, and that's the observation I need you to make. But they do specifically both have 2X's. And I get that the guy in front has 3, but that's not a commonality. So you can't take out 3 because then the second guy would be like, sorry, man, I don't have 3 to give. So what we're going to do is we're going to pull out from these first 2 terms, we are going to pull out x squared. And then we're going to build a little shell for the remnants. All GCF is, ever has been, ever will be, is just reverse distribution. It's literally undistribution. So if you undistribute x squared from both of the terms, what's left of x to the third? He's got x left over, doesn't he? He used to have 3, we took 2. He's like, I got 1 left. What's left of minus 4x squared? Minus 4. Perfect. So we can say that the first group is done. Any questions on step 1? This step is really important. I generally do a pretty good job. I don't know, some things I say and I don't do a good job. This one people tend to hear. You have to do this next step or it's going to haunt you. You need to take the sign right after the wall and copy it down. Half the time it's going to be a plus, half the time it's going to be a minus. So you're going to take that sign and you're going to copy it. That really matters because that will determine whether or not we're going to have to play a game of sign switching. Are we GCFing out a negative or not? In this case, no, we're pulling out a positive. So now we change our thinking again. And this time you now ignore what's on the left side of the wall and you focus on the right. What do both of those terms have to offer up to the table? Three. They both have threes, don't they? We all know that 12 is, of course, 3 times 4. So you could undistribute a 3 or factor or GCF a 3 from both of these terms. So we're going to pull out a 3, and then we're going to build a little shell. And the shell is always where your remnants will go. So you just have to keep asking yourself, if I pull out or divide this much, what's left? If I had 3x and I pull out 3, what's left? X. Correct. And if I had minus 12, what's left? 4. Good. I now have to embark on the hardest part of this lesson, the only part of this lesson that is difficult. And it's optional, but I feel like what I've learned over the years is if I don't explain this part, I don't think you ever really have an idea as to why you're doing what you're doing. So if you, I'm going to scroll. In fact, I'm going to make a whole new page because I don't want you to be looking at that original problem. If I gave you this, A times B plus C times B. Forget what we just went through and just talk about this with me. If I asked you to pull out a common factor from those, do they have one? What do they both have? So you would agree, and you don't have to agree to be polite, but you would, I hope, agree that because there's a B in this one and a B in this one, that I can undistribute that B and pull it to the front, correct? What's left when I do that? Don't forget here in a moment that you just answered that question because I'm going to make you answer that question again. It's just going to look more confusing, but it's the same thing. Let's do it again. If I gave you star times happy face minus check mark times happy face, what would you say both of those have? So you would agree, and I'm just trying to drive this point home. So in a minute, you don't get on my case about, wait, what did we just do? It's the same thing. You would agree that these both have a happy face. So I'm going to pull the happy face out to the front, leaving me with what? Star minus check mark. I could do this all day. If I were any good at drawing, I'd do like puppy dogs, but they look like platypuses and stuff like that. So I can't draw. So that's why I revert to dumb shapes like this. The idea is if two terms have something in common, we can pull it out, right? Okay, so don't forget that you agree with that because now we're going to go and apply it to this. Would you agree that the purple term and the green term both have something that's the same? What is it? What is it? It is x minus 4. So as you just showed me that you understood with A's and B's and C's and check marks and happy faces and stars, as you agreed a moment ago, then you must also agree that I then am within my rights to take this commonality, the x minus 4, and pull it out to the front. And let's go back and look at what we did after we pulled it out to the front. Remember how we put the leftover stuff in parentheses and rebuilt? So let's go back and talk. What's the leftover stuff? X squared and that is how you factor by grouping. You can see how this will obviously, present multi-step problems because your math teachers, math programs like Delta Math and worksheet generators like to make those second ones be, I don't know, like a difference of squares or something like that. In this case, this is a one-step problem and it's over and it's dead. Okay. Again, almost everyone in the history of my teaching has understood this page. But somehow when we apply it to this page, it just looks different and people say, I didn't see it. Keep going. You'll see it. We're pulling a common factor out to the front. That's all we're doing. Let's go again. Round 2. X cubed plus tree x to the tooth minus double x menos 6. Step 1. What is it? Let's go. Step 1.
Draw the wall.
Built that dang wall like that. And again, the wall is merely a visual aid. It is, of course, optional. It will help you. It's kind of like writing A and B when you're doing cubes. It's important. All right, what's the commonality of the first group? They both have x and they also have another x, so we can pull out x squared. You would agree that they both can say, I can bring that to the table. And now we rebuild. Build a little shell, and the first group will be complete. What's left of x cubed? You took one of his x, you took two of his x's, he's got one left. What's left of plus 3x squared?
3.
Plus 3. Signs are mandatory. What is the next step?
Minus.
You bring that minus down. Good for you. Right there, like that. Now, forget the signs from here on out for the next 30 seconds or 20 seconds, whatever. What simply do 2x and 6 have in common? Notice I did not say -6. 2. So I'm going to attach a 2 to my minus, thereby telling the math gods, I'm not pulling out a 2. I'm pulling out a -2. And that matters because, as you know, when you distribute negatives, the signs change. So guess what? If you undistribute a negative, the signs have to change back. So what's left of -2x if I pulled out the -2? Positive x. What's left of -6 if I pull out a -2? Positive 3. And again, we note that there's a commonality. We note that this term, and I'm using this word on purpose, what I'm underlining in purple, and I'm being very deliberate with my pen, that thing is called a term. It has multiple parts, but multiplicative parts can make a term. Terms are separated by pluses and minuses. So we would all agree that the purple term and the green term have something in common. What is it? The x plus 3. So we're going to pull it out to the front, leaving us with then the leftovers, which are the red and yellow, meaning x squared minus 2. Are we done, or do we press on? We're done. Again, x squared minus 2, you feel it creeping in. He wants to be a difference of squares, but we're not quite there yet. So that one is done. Okay. Round 3. 3x cubed minus 6x to the tooth plus 4x is minus 8. I'm going to just drill and practice now. Okay, we got this. What's the first step? Draw that wall. Do it for yourself. Oop. It's a visual aid. What is common to the first group? I agree if you say x to the second, but you've got to pull out the 3 also. So for the first time in our examples, we've seen the first group not just have x's in common, but also you would agree that the 3 and the 6 have a common divisor of 3. So we pull out 3, and we also pull out a couple of x's like this. And then we rebuild. What's left of 3x cubed if you pull out 3x squared? Just an x, one lonely x. What's left of minus 6x squared?
Minus or plus 2x.
Minus 3.
Nope,
Oh.
just minus 2.
Oh, yeah.
There's no x's left because remember, we pulled out both of his. He gave everything he had. His homie to the west had one extra, so that's why he got to have one left over. But x squared's like, I gave it all, man. Group 1, done. Next step, copy your sign. Whoop, which plus? And then begin the math. What do 4x and 8 have in common?
4.
So you're going to bring down a 4, and then you're going to rebuild. And what is left?
X minus 2.
X minus 2. The question invariably that any normal student at this point might start to ask is, when I get here, can't I just make this green one look like the other one? And the answer is no. If a polynomial was not meant to be factored by grouping, then this won't work. Okay? So don't think you can just brute force it and like go, oh, I just need it to look like the other one. I'll just write it down. Your practice is going to insinuate that that's the case. I'm just giving you problems that keep working so that you can learn the process, but don't assume, don't just brainlessly write the same thing in the white parentheses as you did in the other white parentheses. That's no good. No good. Because then you're going to come up with factorings that don't exist at some point. What's our final answer here?
X minus 2.
Times.
3x squared plus 4.
We have anything good here? Is there any meat left on that bone? Nope. 3x squared plus 4 has really not much going for him. So for the third time in a row, one and done. On to the next one we go. Let's go x cubed plus 10 X squared minus X minus 10. Step 1. Build a wall. Next step. We agree that the first group has X squared in common, no numbers in common, but the X squared I could get out. So I'm going to pull X squared and then I'm going to rebuild. What's left in my rebuild? Perfect. X plus 10. Next step. Bring down the minus. Remember that minus is huge because it's going to remind us. I mean, we need it at the end, of course, but it's also going to remind us to do some sign switching. What can you get out of X and 10? 1 is the perfect answer. A lot of times people say nothing. And generally speaking, I agree with that assessment. But in this case, I can't not put something there because as you've seen, that's something that I'm about to write. I need for my second factor, right? So to say they have nothing in common would have been incorrect. So thank you to whoever said 1. Was that you? Nice job. 1 is a very important common factor in this case. What's left if I pull out a minus 1? X, change the sign 10. And that would be where you'd catch yourself. The good thing about grouping is let's say you erroneously put this purple minus sign here. You wouldn't go all ghetto math and change it to a plus just so it looks like the other guy. You'd look at it and say, why does it not match? And then you'd go, oh, that's right. It's because I pulled out this negative and I got to change that minus into a plus, right? So you can assess yourself if you get it wrong. All right, what is my answer?
X plus 10
Times.
X squared.
Done?
No.
No. And we've practiced enough that if you were to say, yes, we're done, then you just have not been here for 3.5 weeks. That is a glaringly obvious difference of squares. So it took us 4 examples to get there, but now we see one of the offspring producing its own offspring, right? So the second factor is a difference of squares. So just like we've been doing with multi-step problems, we're going to bring the trash down, and then we're going to do what we do. What does X squared minus 1 become? X plus 1, X minus 1. Differences of squares are always plus minus pattern, square root, right? Questions so far? Let us press on. Next one, 4x to the third plus 16x squared minus 9x minus 36. Just going to keep asking until it's just stuck in your head. What's step 1? Step 1.
Wall.
Zoom. Go all Trump mode on this sucker. Build that wall, right? What are we going to do after this? Pull out something. How much did you say? 4x squared is the money answer there. The 4 and the 16 say you can divide us both by 4, and the x's work together to say, well, this is the best we can do. Take a couple. And then we rebuild. What's left? X plus 4. If you're ever not sure, just redistribute it. Take this times this and this times this and make sure it equals this, right? I mean, that's how distribution / factoring and multiplying are like whoop, back and forth, right? All right, so that one is looking good. What's the next step? Shoop, bring down your negative. He's a minus, but he's kind of gonna take on the role of a negative at some point, maybe. What can you get out of 9x and 36? 9, leaving behind what? X, change the sign 4, right? Remember to always change that sign when you bring down a minus. That's our answer.
Parentheses X plus. X parentheses 4x squared minus 9.
Done? No. And again, your expert trained eye spots that difference of squares immediately. No way is that one slipping by you. So we're going to bring down the trash. The X plus 4 can just get copied down. What is the factored version of this difference of squares right here?
2x.
Nice job, Landon. Square root plus square root times square root minus square root. That marks the little bit past halfway point. We still doing okay? All right, let's blow through these last 4. I would guess by now you understand the process. 18x cubed plus 27x squared minus 8x minus 12. Step one.
Whoa.
Yeah. Oop. Next step.
Take out 18.
You can't take
Nine.
18, but you can take 9. And you want to be careful. And if you do say something like 3, all hope is not lost, because what happens is if you only pull out a CF, a common factor, then you can go back and troubleshoot later when things don't work, because it might be not working because the problem wasn't meant to be done, like it's not factorable. It also might not work because you pulled out a CF and not a GCF. So eventually you'll spot, though, that these can both be divided by 9. So we're going to pull out a 9, and we're going to pull out a couple of X's, and we're going to rebuild what's left.
Plus 3.
Perfecto. Next step.
Minus.
You. And what can you get out of 8x and 12? 4. Leaving behind what? 2x. Change the sign. 3. Notice I don't say plus or minus. I try to keep saying change the sign so that you remember that pluses become minuses, minus become pluses. Like, let's generalize it and just say change the sign, change the sign, change the sign. So my answers are obviously going to be white. That's the common one. Multiplied by red and yellow leftovers, 9x squared minus 4. And for, I believe, maybe the 4th straight problem or so, what do you see? I spy with my little eye the difference of squares. And so we're going to bring down the trash of 2x plus 3. And then what does that factor down into? 3x plus what?
2.
2 times 3x minus 2. Final answer. Feeling the flow, the vibe? Are you in tune with it? Are you becoming one with the grouping? Okay, good. Let's go again. Step 1. Parker, would you like to try to do this problem on my writing tablet? Would you like to write on this and actually do it? Is everybody okay with that? Have you ever done this before?
No.
Okay, so let me just give you a quick tutorial. When you hover the pen over, you see the crosshairs. When you get within about 1/4 of an inch, you can see the crosshairs. To change colors are up here in the corner. If you want to erase something, your erasers are right. Do you see where I'm clicking right up here? Those are your erasers. And these are your pens. And you generally want to avoid the thicker pens because they're a little bit much, right? And you can also hit the undo button. So I'll give you a thin white pen and it's all yours. And we're going to marvel at yours. Can I keep this on the recording?
Yeah.
Yeah, baby.
Glad to write on this.
Oh, yes, please.
This way. Yeah. Yeah.
Prepare to be wowed, blown away.
You got drawn a wall. Oh, yeah. It broke. Oh, sorry. Here, undo. This is so much harder than it looks.
Right there's a good looking wall.
Alan, is what can we pull out of this? 4. X word.
Hey, I know what the learning curve is. You're not going to get any flack from me, man. This is hard. I know. There's a steep learning curve. Don't think about it so much. Just write normally like you would, and just don't think so much about it. Just
it's backwards almost.
really.
That's funny. All right. It's forward. Wow. Can I bring down two items?
Unless they change the rules of math, I'm pretty sure 3 can't be divided by 2.
Oh, what is going on?
But I do know it's that new math.
That's one. Well, this is what you know what it tastes like. Oh my gosh.
You're fine. Fine. I thought that was a pretty good one.
Let me move my parenthesis over.
Oh, is that what that was? A parenthesis? I thought it was a sea creature.
Oh, hey, this is harder than one. Oh, cow. Wow, that's something.
Would any of you other little critics like to try after Parker?
Yes.
Sure.
Okay.
Yeah.
And Caleb's like, bring it. I'm gonna.
Bring it on.
Go build this, you just go.
I don't mind using a little extra time for this. We can work on our assignment on Monday. I'm not worried about gobbling up some time. I think this is good for you guys.
Oh my gosh, this is so hard for no reason.
Can you just erase that and just try and I'd just like to see you make an actual parenthesis that doesn't look like that.
See?
Right.
All right.
Just have faith in yourself, bro. Just go. Just make a parenthesis. Go.
It's opposite. It's backwards.
Yeah.
Are you seriously?
It's skill right there. Upside down.
I've been doing this for years. No one has ever had the board upside down before. Did you have it upside down?
The whole time.
That's so right.
Upside down. That is some skill.
Yeah, honestly, you look at this now. Look at him cooking now. I couldn't figure out what you meant when you kept saying things were backwards. It's like, what's
why is
home?
this so
What's he
difficult?
talking about, man?
Like a secret group there.
What is the quiver? What is that?
4.
You keep going, Parker. You do you.
That's a 4. Okay. I was like, why is this so difficult? And
Well, now, yeah, I was having a hard time figuring that out
I'm
too.
glad Morgan is vigilant and understanding why.
Okay, well, I actually knew he handed it to you upside down.
I'm sorry, I didn't even really think that that would matter, but why would I assume that Parker knows Parker? That was great.
Upside down, that was way more.
Michaela,
What?
make sure I should have said this to Parker.
It's like that.
Make sure
It's like-
make sure the buttons are in the upper left. Make sure the buttons are in the upper left-hand corner.
Ain't no way.
The button should be in the upper left corner. Are the buttons in the upper left corner? Then yes, that way. He did. He was trolling you. So what you're going to want to do now is go move your mouse, move your cursor down to the bottom. You see that little high five hand? Grab that. Just yeah, remember, don't touch when you're hovering, and then click that. Click the hand. Now grab the screen and pull upwards. And that's how you can make like more paper. Okay, keep going.
Oh, look at that beautiful line.
Now go back down to the bottom and click the far left button, the pen. That'll take you back to writing mode. That's the one. Yeah. Okay, your next problem is 4x to the third. Oh, Parker, she's already showing you what's up. Minus 5x
He
squared.
has to do it backwards.
Now that will never happen again. Minus 64x plus 80.
When it's not.
I'm just cooking. I am cooking.
Oh, yeah. Or just be 4x.
4x. I'm sorry that you got this one, but does anyone in this room want to pitch in? It's not as obvious as you think. Does anyone know what the GCF of 64 and 80 is?
It's not 8.
It's not 8.
6.
It is 16. So the fancy fun fact for you there, everybody. 16 times 4 makes 64. And then 16 times 5 makes 80. Way to change your sign. Nice job. Way to go.
Yes.
Square.
I'm not gonna have room.
You want to see a trick? Okay, grab the fourth icon, the little arrow. No, that's not the arrow, right to the left of, go down. To see the arrow. Yeah, that arrow right there. Click that. Now pull and draw a box around all that stuff you want to move to the left. Just the stuff you want to move. Boy. Okay, so you want to start kind of upper left and drag the box all the way, or upper right's fine too. Yeah, you pick. Doesn't matter. There you go. Now let go. And now click on like the edge of the box, just like not the corner, but the edge. A top or bottom would be probably better because go ahead, just nope, move to the right. Well, your other right would be great too. I mean, it doesn't, you pick. How about you just hit the undo button? This isn't going well. Next time I get the board back, I'll show you what I'm talking about. Yeah, that was more efficient. I should have just let you do that in the first place. I'm sorry.
No, you just.
Oh, boy.
I think my head.
Not quite as critical of Parker now, are we? Hmm.
Right upside down.
For a third.
Oh. Yeah, I was right upside down for straight her.
Ain't gonna happen, bro.
I really.
Yeah, I mean, listen, all things considered, all joking aside, that was really good. We have one more. Who wants it?
I want it.
Landon's got it. Okay, let's go. We could whip up another one for you there, Will.
No.
Buttons in the upper left.
That.
This is right.
There's a word somewhere on the board, Huion. It's like the brand Huion. If you can read the word Huion, then it's facing the right way. The homie's not even listening to me. Okay. All right, 3x cubed.
Well,
Plus 2x squared.
this is way harder than I thought it would be.
Plus 48x.
You're gonna walk in.
What? Don't write your eights.
Plus 32.
It's like that.
All right, let's let the man cook. Here we go. Nice work there, Trump.
So, where?
Congratulations.
It was three dots. That's Susie. I'm kind of cooking. What? Oh, that's a bad plus. Make it. Oops.
Good save.
8,
16.
16.
Mhm.
I'm assuming it goes in 3 times.
Yep.
48.
Absolutely. That's a good assumption.
It might be a one step or.
So it's for
Oh. I was.
I think it's just a new problem. You should have known.
Oh, I'm gonna have. Oh, it's done. Oh, I am. No, no. Yeah.
Plus 16.
That's a summer school.
Houston.
Oh, yeah.
Oh, 99. Whoops.
Can't do it.
Yeah, we're done. Hang on.
You want to try one, Will?
Yeah, that uses your brain way too much. I don't know how you do that.
I'd been writing on that board for like
This is.
4 hours a day for 24 years. I didn't start using it until about 5 years into my career, so I do have an advantage of being it.
Nice.
I'm telling you, it'll be better if you just quit thinking about it so much and just let your normal handwriting take over. It's just full send. Just and there'll be some issues, but
I might.
that's the wrong hand, bro. You want the high fiber. Yeah. Mhm. Ready?
Okay.
4x cubed plus 5x squared
There's some good things.
plus 5x squared minus 16x minus 20.
I hardly can see it from this angle.
I can see how that would be a problem, yeah.
My own white. I don't know which one I'm on.
You're on white.
No, you're on purple.
Oh, you are on purple. Yeah.
Yeah, I am on purple. There we go. Now, yay. What goes in one? One. It's where will it? Where?
It's just not like vertical jumping.
Michaela. Mhm.
Holy giant. He wants to show that as a plus.
Five. Well, at least you know. Oh my gosh, at least you know it's a plus now. X.
Oh,
It is an X. Telling the world that it is an X.
There's no X's left, homie. You pulled out all the X's. You better get rid of that X. It's just 4x plus 5. You took out all the X's he had.
Yay.
yay. Oh, nose.
You guys making noise stop, okay? We're not done. That's why you can't drag an activity on like this too long. You guys have reached saturation at this point.
Not going up.
It's okay. You run out of space. You can just write in the space you have because I gotta do something with you. So tick tick. Yeah. Excellent work. So I need you guys to get your Chromebooks out, pop them open, go to Delta Math. Thanks, Will. Nice job, everybody. Thanks, man. Thank you. So I'll just keep this on the recording. I might as well. Am I still recording? Yeah, I guess I am. So I'm gonna have you guys go to Delta Math. I have a code I need you to put in. Our next assignment, we haven't done any Delta Math in this class yet this year, have we? Right. And so it's the right time. Delta Math does a really good job with grouping. I was going to write a worksheet. I always like to check Delta and see if I like what it has to offer. I like it. Sometimes it has two steppers, sometimes it has one steppers. I really thought this is good. So that's why we're going to work in Delta Math. So I'm going to go up here to tools, manage students and classes. And for first hour, I'm going to zoom way in on this like pretty obnoxiously. And then I'm going to highlight for you guys what your join class code will be. Okay. So yours is going to be this top one. I'm dragging and highlighting it in blue. I'll say it out loud. It's 2Z3F4KJ8. You guys have used Delta Math before, so we don't have to go through all the what is this? Like it's ain't your first time using it. So I should see this 0 within the next minute or so, go up to say 15. I'm going to refresh here in a second. And I do see 4. That's progress. I'm going to refresh again. 9. Yeah. Let me just keep up. We're up to 10. We're doing great. Yeah. Let me pull it across to the code real quick. Again, it's the one on top right here. You do not need to work on this today. Once you get the code put in and you have joined Mr. whatever it says, like Mr. Ahern's class, first period or some period 1, I don't know what it's called. Then you may put your Chromebooks away and we'll take the weekend off. We will work on Monday. But I do want to see this number at 15 before okay, we got one more straggler who's still struggling to get in. So we should be. You're going to make me do this again, aren't you? Goodness gracious. There you go. So even folks watching the video, I don't know if they are or not, but they would do this too. By the time Monday comes, I should have all 17 kids on this roster in and we're ready to rock and roll on Monday. Right? You good to go? Will, you good? We at 15? Kabam. Good job, everybody. All right.